Hi guys, I'm Bobsi, and in this video we're going to take a little bit of a different approach and a more proper approach to learning multiplayer in Unity. Now, I actually had a little bit of a course at one point at a university and I really enjoyed it. So see this as more of a lecture, or I want to say a mini course on becoming a good multiplayer game developer. I'm going to go from the very basics all the way from installing the system and even what is networking and how does the server client structure work, all the way to getting you set up with the basic multiplayer concepts and a good baseline to start learning by yourself. Because this is how I prefer learning. I want to get a good baseline so I can start doing things on my own, learning on my own, debugging on my own, and that's what I'm going to try and do for you. In the past and in general with my videos, I've always done kind of quick and dirty setups. Don't get me wrong, not inherently dirty, but you get what I mean in the sense that, we just get it to work, call it a day. This video is going to be very different. I'm going to take some more time. I'm going to try and explain these concepts properly, and we're going to move through them just one by one and really take it from there. So first of all, just who am I and why am I in a position to teach you anything? Well, as I mentioned in the intro, I'm Bobsi, and I'm essentially a game developer who focuses a lot on multiplayer game development. It's sort of my specialty and what I enjoy doing. I turned full-time on multiplayer networking in 2022. So at this point of recording, I've only done it for about 3 years, but that being said, I've done it quite a lot and quite diligently, so I think I'm at a pretty good spot with it. But that being said, I've played around from game development all the way from 2010 when I started sort of finding it a lot of fun modding games and learning like that. And then really growing from there, as I think most game developers have. We're typically self-taught because it's a very passion-driven field. And also, full disclosure, I am the co-owner and co-developer of the PurrNet networking solution, which is what I'm going to be showing you how to work with here. This is not inherently trying to sell you the system, because there is not even a pro version, it's completely free, but also in the sense that it's just a solution that I prefer. We've sort of built it and set it up as our preferred networking solution. However, it's very similar to the likes of Mirror or Netcode or Fishnet. So if you work with PurrNet, you'll also very easily get a good idea of working with these other solutions, or it'll be easy for you to move around between these very normal solutions because we sort of have similar structure, similar code, similar approaches. All right, so moving into it, what will we be going over here? And of course, there's this little slide presentation. This is really only 5 minutes, so it shouldn't take a whole lot of time. But essentially, we're going to go over sort of what and how of networking, and then we're going to go into a bit of how to think in multiplayer. This is extremely important, and I genuinely don't think you can become a really good networker if you don't understand this concept of how do you think in multiplayer, because it's a very different approach from making single player games. And then of course we're going to move into the networking concepts in Unity, anything from remote procedure calls and synchronizing to spawning and setting up the actual system. Alright, so moving right into it, let's just talk a little bit about general networking. You don't have to really strongly understand everything of this. The main thing I want you to understand is what's on the top right side of the screen here. But essentially, let's just go over them. First of all, local multiplayer versus online multiplayer. A lot of people seem to confuse this. And the thing is, it'll generally work the same. Whether it's online or whether it's local on your network, it'll still run through a networking system, so the logic will pretty much run the same. So I've had a lot of comments saying, hey, can you do LAN with this, or can you do online with this? And the answer is yes, with all these systems you can. It's the same logic, same game you're making essentially. So whether you want it to be local or whether you want it to be online. Obviously local is, I'm not talking about split screen, I'm talking about still across multiple computers on the network. Split screen is a whole different case. That has nothing to do with networking. But moving on from that, there's also the different essentially architectures of, well, server structures and how the logic moves around on network. Now, I don't want to go too deep into this, but what the most systems use are the client server architecture. And that's essentially what you see here on the top right. And we'll get into that in a little bit. I just want to mention the others. The other one's the peer-to-peer architecture, essentially where all the clients are sort of directly intertwined together. This is very uncommon to see in modern setups. This was more common early days networking. Then there's also the concepts of server, client, and host. This is very important that you understand this as well. It's very simple, essentially. The server is the one that acts as the communicator between all. The client is the one that's sort of connected to a server. So as you can see here, only the server and the client communicate, server and client communicate. Notice how there's nothing between the clients here. And the concept of the host is essentially just one that acts as both. In this case, the server is here. And then you might think that when he then becomes a client, he plops in a new bubble of his own here and connects to the server side of him. But that's not actually the case. The server up here sort of becomes the client as well. So he just communicates locally with himself. There's not really a difference there. And then there's the idea of stateless servers. Some setups use this, but it is it is a little less common, but it's still quite utilized today. And it essentially just means that normally when you run a server and client setup, both the client and the server will be running the game. So they will both have a understanding of what is the state of the game, you know, who is shooting who, what is a zombie, what is everything, right? It knows the game because it's playing the game, whereas a stateless server doesn't actually play the game. I want to say it's almost like a database that can also run functionality, if that makes sense. I know it's a little confusing, and again, I don't want to get too much into it. The client-server architecture is the one I want to talk about here. And essentially, this is what you have to visualize and think about when you work with networking. Because networking is all about where does what logic run and where is what logic stored. In general, to make it easy on yourself, the obvious response is have it done on the server. If there's logic common for everyone or data that is relevant for everyone, the typical answer will just be have it on the server. And essentially that's because all the clients are obviously directly connected and intertwined through the server. So no matter how many clients we have, they will all only go through the server. And that's essentially two directions of information, right? There's the client requesting something from the server, and there's the server's response to a client. That's really the two ways of going about it. So when, and we'll get into that a bit later, but essentially when we navigate networking, we'll be navigating it typically through the eyes of a server or through the eyes of a client, sort of requesting the server to do something. And in which case, still pretty much through the server. We'll get into this in a little bit. But moving on to just the multiplayer mindset. And this is where it's really, really important, because you won't be able to debug multiplayer if you don't understand this concept. So first of all, let's just take it. Actually, let me just pull up Paint here. I know it's not going to be beautiful, but it is going to be functional, hopefully. Let's say that we have a cube here, or a box, right? And on your screen, you move this box. But on my screen, it's still here. A lot of developers sort of just lean back, jump in our Discord, which you're more than welcome to. Link will be in the description. But immediately say something's broken, it doesn't work. Because, well, one person sees a move, the other doesn't. Why is that? And this is essentially where you have to, once again, go back a little bit and think what's going on here. Something is happening now on a client, but the other client, or the server for that sake, isn't seeing it. Well, it's because you're never sending that to the server or to the other clients. You're not letting people know that this has changed. And this is essentially what the concept of synchronizing is about, is I change something, the system now notices something has changed, and we let everybody know. And this is inherently because we are not in the same world. And just going through these points real quick, we're not in the same world. You have to understand this. We are not in the same world. Something is not synced. It's because you didn't sync it. That was what I just mentioned. And again, I can't stress it enough. We are not in the same world. And what I mean by that is that you have your local version of the world and I have my local version, right? So let me try and go back here and let's draw two computer screens, right? One screen is yours, one screen is mine. Like so. And on these screens, we have a red box here, which is because we've just started the scene. So we both see the exact same thing, and a blue box here, right? Cool. So right now we've both just started the game, but think about it in single player terms. Think of a single player game, right? If both you and I start up Tic-Tac-Toe or The Witcher or any game of that sake that is single player, we're still seeing the exact same thing. Does that mean we're networked? No, we're not in multiplayer. It's still a single player game. So that means if in your game, you now move this box, it's not inherently going to move on my screen or vice versa, right? That has to be up to the network. These two have to be connected. But what's essentially happening is when this connection is created, that doesn't automatically mean that they are sharing a world. They're still in each their own world. What essentially networking is all about is about triggering this local world to think that it's networked. And that's what the networking system will do behind the scenes. So behind the scenes, what a networking system like PurrNet, for example, they will do is they will ID them, right? So this will be 1, this will be 2, this will be 1, this will be 2. And essentially what's happening now is as we choose this to be a networked object and synchronized, what the network will be saying is object 2 has now moved to this position, so it'll mimic it on this screen. But once again, and this is an extremely important, and not even a detail actually, an extremely important fact, is that this is still a local version of the game and this is still a local version of the game. They are not the same world. They won't be the same world. We're just sort of mimicking the idea of the same world. And this was really going back to that cube concept of something moved on my screen, it didn't move on yours, what's going wrong? What's going wrong is you're not understanding networking. You both have your own local version of the game running, and you're not doing a good job at mimicking that on the network. That's what's going wrong. And just going back to the presentation, that's what I'm trying to say here, is that we are not in the same world. You have to understand this concept. And I know it's a bit tricky, because automatically when you think of multiplayer, you think of all these games where you're running around in the world together, dynamically seeing each other. And that's true. That's what we're going to end up making. But even take World of Warcraft, for example. You're still running a local instance of World of Warcraft. I'm running a local instance of World of Warcraft. We are just connected, and the network and the computers are essentially sort of almost, I want to say, tricking each other to think that the objects are the same. But they aren't. They're not the same. They just have the same IDs on the network, so we can use that to transfer data between them. Let's now say, oh, we want to change color of this cube. Well, then we're just going to say cube 2, change color. So over here, it'll do cube 2, change color. And then it'll mimic that, right? And that's sort of the general idea. And it's really important that I stress this a lot, because without this understanding, you won't be able to debug networking. If you just think automatically the network will be the same, well, it won't. And that's not how networking will work. So we'll get into that in a little bit. And actually, let's jump into Unity. Also, be aware that we have the PurrNet documentation on GitHub. I'll, of course, also leave a link to the description, or in the description, to this. And we have a lot of good things here, for example, like the installation setup, the getting started, and so on and so forth. And essentially how you get started with a bunch of stuff. And I even have some full game guides also on my YouTube channel. Now be aware of my YouTube channel here. I also have the PurrNet multiplayer or Unity multiplayer guides with PurrNet here, where we're essentially going over a lot of the concepts that we're going to be covering in this video. There's even more concepts in here, but as I mentioned, these are sort of the quick and dirty versions of them, or quick explanation, right? As you can see, 5 minutes, 3 minutes, 5 minutes, where this video is probably going to be a little bit longer than that. All right, so let's move through it, and let's start by just installing PurrNet. First of all, in order to install it, typically you can do it through the asset store, as you might be used to with Unity. But you can also install it through Git, which is what I typically recommend. And if you want the very latest version, you can hop on the dev branch here. We just can't ensure that it's always completely solid, but in general, we'll have the newest stuff pushed to this. Now, another thing you will actually need, if you want to install it through the Git link, with Unity, you actually need to have the Git SCM installed. So all you'll have to do is just head in here, download it, install it, and you might have to restart Unity, or maybe even restart your PC, depending on what it prompts you to do. But other than that, it should just work. So what I'm going to do is on this link, purrnetgitbook.io, we've gone to the installation/setup, and I'm just going to copy this link here, or you can also copy the release link. That's entirely up to you. Go into Unity, into Windows, Package Manager, and then up here on the little plus, I'm going to hit package from git URL, paste it in, and hit install. And just so you're aware as well, PurrNet is supported from Unity 2022 and forward. We mostly test in Unity 6 and forward, just since it's the newest version, but it should work from 2022 and up. Now, what we're going to be going through from here is we're essentially first going to set up the scene just so it's ready for networking. We're also going to set up our testing setup. So actually, let's go do that really quickly. So heading back in here, we're going to go download a system that's called ParrelSync. If you just search for ParrelSync, there's also multiplayer play mode. If you're already familiar with it, feel free to use it. But I mostly use ParrelSync. So I'm just going to head in here, and I'm just going to download the latest version of ParrelSync. I'm just going to hit download here on the Unity package. I'm going to open up Unity, and I'm going to run the installation here. Cool, and I'm going to hit import. All right, great. Now we're going to get into what ParrelSync does in a little bit, but it's going to allow us to help test the multiplayer setup. So first of all, let's set up the scene. What we're going to do here, and I've already just set up a super basic test scene. There's nothing about this. This is a Unity 6 URP project. So I essentially just hit new project, selected the universal 3D, named the project, and hit create. And now I'm essentially here, and I've just set up ground and a cube. That's all there is in the scene right now. And we can actually just quickly give this cube a material too. Cube, plop that on there. Let's make it, I don't know, cyan. Let's make it red. There we go. Beautiful cube. Cool. Now let's make a new game object here and just call this the network manager. And just for good measure, I always like placing things in 000, although you really don't have to. Now we're going to add the network manager script to this. And as you can notice, that's already automatically been added a UDP transport. But I'm going to mention what that does in a little bit. First of all, let's focus on the network manager. First of all, we have to select network rules. This is something, as far as I'm aware, that's fairly unique to PurrNet. And essentially you can make your own network rules. They just sort of change how the network works. The unsafe rules will be the ones that are relevant for 98% of you. If you're new to networking, learning networking, I recommend just using those. Also, if you, just making a co-op game, a fun game with your friends, whatever, like you don't care about essentially anti-cheating or whatever, just pick the unsafe rules. Regardless, following this video, still, I would say pick the unsafe rules. Also, we need some network prefabs. You can see that's also marked with yellow. I'm just going to hit new and it'll sort of create it itself for me. All right, cool. Now, starting from the very top, right? So first of all, we have these auto start flags, and you notice up here it says during play mode, this instance will start as host. This now means we will start as both server and client. So when I hit play, you can see both the server field here and the client field here are green, meaning they're both started. All right, cool. Also, if you want your editor to be a little bit quicker, you can go to edit project settings editor. And then at the bottom, we can say do not reload domain or scene. This just means now we will essentially start the editor instantly. Be aware there could be some artifacts with this, so if you already have a big game going or whatnot, don't do it. But I like doing it just for the purpose of being quicker. Okay, so the auto start flags here essentially are a part of PurrNet here, which just helps you with who should just start automatically. You can also just put none in both if you want to. Hit play, and then you can just hit these buttons yourself. Start server, start client, and there we go. Now we're connected as server, we're connected as client. And as you can see, there's one player, which is obviously ourselves. All right, cool. So the transport layer, or the cookie settings, sorry, very quickly. The cookie scope essentially just handles storing the existing players. So if you've already, let me go back to having it auto start as host. If you've already started the game and a client joins, client leaves, and then he joins again, the cookies are essentially responsible for knowing that it's the same player. He'll be giving the same player IDs, he will be given the same ownership and everything like that. Cool. The transport layer here, and the transport layers in general, we have plenty of transports. As you can see, all these transports, and there are more you can download online that people and users will also create. But the transport layers are essentially what's responsible for actually sending the data. You don't have to think about this a lot. The only thing you really have to think about are these fields here if you ever want to set up like a server, or let's say you're playing locally, well, this is where you'd want to add each other's local address to connect, or essentially you want to put in the server's local address here to connect and the same port, and you'll be able to connect to each other. And that's essentially what we're going to utilize as well. 127.0.0.1, that is always the local port, so that should always work. Now the network prefabs are essentially just a list of all prefabs that we'd ever want to spawn. So you can see it will just auto-generate, and it should essentially handle itself. But if I just to show you, just make like a test cube here, test networked object. You don't have to do this, I'm just showing you. And we put a network component on this. Could just be an empty network identity. You might rarely actually want to put this on anything, but let's just say I put this in the prefabs folder. You can see when I click in here now, this test networked object is here because it's ready to be spawned by PurrNet. But we can just delete this. We don't actually need this object. Okay, cool. So that's the prefabs, and that's essentially what the network uses to cross-reference objects with, right? So it's important that this list aligns across all clients. It typically always should. PurrNet should handle that for you. But it might be good to check if there's some weird thing going on. Let's say you're trying to spawn one thing and on the other screen another thing spawns. It's probably because this list misaligns. Because essentially it's just sending an ID, right? PurrNet is saying spawn index 2 in the list, and then it'll spawn index 2. Okay, next thing was the network rules, and then this visibility rules always visible. You don't have to think about that right now, but essentially the visibility rules, just keeping it very simple, can be a rule set. You can make custom rules. You can see we also have a distance visibility rule, which can be something like if you're too far away from something in the distance case, then don't show it, don't network it, don't send data. It's essentially an optimization thing, which is why I'm saying don't think about it right now. Then there's the authentication layer, which is essentially just a layer that will say, accept or decline whether a client is allowed to connect. If you have no authenticator, which you will in a lot of cases, that's just no check and they'll just always be able to connect. But this could, for example, be, let's say you have a database where you've banned players. Well, then the authenticator should get the connection and all the information. You should check it against the database and check whether are they banned or not, and whether to allow them to actually connect or not. And then there's the tick rate. This is how often the network will essentially update. Meaning when you try and send data, it'll wait for the next tick. So if you only have a tick rate of, let's say 2, every half a second, the network will update. In the case of 20, it'll be every 0.05 seconds, the network will update. So it's essentially similar to your frames, just the service frames. In a lot of games cases, 20 is perfectly fine. Let's say you have a game that requires really high precision or really high performance. You might want to go to 60 or even 120. But in our case, let's just stay on 20. All right, cool. So that's the network manager gone over quite briefly. The reason why I go over this quite briefly is because most parts and most games and most setups, you'll really just want to set this up and rarely look at it again. You know, it's one of these things, it just has to work. But let's get to actually testing. So remember we imported ParrelSync. So I'm going to go up to the ParrelSync tab here, go to the clones manager. I'm just going to put it over here and we can hit to create a new clone. Now a clone will essentially just be a copied instance of your Unity project. So when you work with ParrelSync, it's important that, I'm going to hit open in editor here. It's important that you don't make changes on the clone, you make changes on the sort of the main editor, which is the one we have here. And they will be named differently. The other one will be named PurrNet tutorial course clone. And essentially when you make changes on the main editor, it should reflect, or it will reflect onto the other editor that you have. All right, great. So here we have the other editor. And already if we go into the network manager, you'll notice it says during play mode, this instance will start as a client. As you can see here, that's because the client start flags also have clones ticked, whereas the host doesn't. If we hit clone here, you can see now it'll start as a host, but we're going to hit clone off and now it'll start as a client. So this means that if we now go here and I hit play, we go in here and I hit play. Notice how now it says player count 2. You can see this one is connected as a client. If we go into the host, it'll also now say players count 2. And this is connected as both the server and the client, meaning that we are now connected to each other. You can also see the list of players here and what's relevant, which scenes they're in and how many objects they own and whatnot. But essentially you can now see now both players are connected. And it's really that easy getting a connection started. That's the magic of these networking systems. That's not just PurrNet. That's what a lot of these other systems do. I'm just going to move this editor to my other screen. I'm just making my own life easier here, but of course I'll show you anything relevant. Okay, now let's get into actually using PurrNet. So now we've set up the scene. Now we have to think about what can act on the network and what doesn't, because everything that's in your scene isn't inherently networked. And actually, let's try and connect them again. And let me start showing you here. So let me try and move the cube around. Let me move it, for example, over here and up a little bit. And if we go to the other editor, notice how the cube hasn't moved. The cube is its own thing here. And this is exactly what I talked about. They're each their local game. We might be connected, but that doesn't inherently mean that they know what is the same thing. What needs to be copied, what doesn't need to be copied, and so on. So thinking with that in mind, let's go back to my main editor here. We need to think about how can we synchronize this. So first of all, we need to tell the network that this is an object on the network. But luckily for us, PurrNet actually handles this already. So a network identity will do this for you. So let me do that, save the scene. If we jump over here, it'll ask us to reload the scene. Now you can see this also has the identity. Now let's try and start both of them again. And now notice how this cube now has this little bar down here on the network identity. This is how we see what it essentially is for the network online. So you can see the local player is local player 001, and here it'll be 002. That is indeed correct. But also in here, you can also see the ID of it. The server ID of it will be 0, and the owner ID is none because it doesn't have an owner. Right, so this now means it's spawned. If this wasn't here, it wouldn't be spawned. So that's already a great start. But let's remove this again because we don't actually need it. Pretty much every network script is a network identity script. And we'll get into that in a little bit. But what we can do is we can add the network transform. This is essentially what automatically syncs position over the network. So going in here, I'm going to save the scene now. I'm going to go over here and reload the scene. So now they both have the network transport. I'm going to hit play on the server, going to hit play on the client. Now I'm going to go onto the server because it doesn't have an owner right now. So that means the server will be the one controlling it. And I'll show you a bit more in the component in a little bit. But notice how now I move this here, move this here. If we go onto the other screen, now it has also moved. Now, this is great. I can also show you actually live if I try and move it here. Notice how they're synced. So they both move live, right? Cool. So we already got that working for us. Now, going back into just the network transform really quickly, it's always a good idea getting familiar with the components and the settings that we have. But mostly the default settings will work quite well. But what's relevant right now and what I'm going to show you is the owner auth. It essentially changes who is allowed to move it, who is allowed to control it. So if I now start the server here and I start the client here, PurrNet luckily has some things to help us do this. So notice how it doesn't have an owner, which means if I try and move it on this right now, I'm not actually allowed to, I can't. Like I try and set it, nothing changes, just jumps back. I can't move it, not even in here in the scene, not allowed to move it. Because I'm not the owner, because we're on the client right now. But if I go down on network transform or any network script for that sake, I right click, I go to PurrNet and I go to take ownership right here. Boom, now you can see the owner ID is 2, and you can see that's also the case for the server. You can see that it's the same owner, which now means now I can move it, which means I control this. Now you can see on the server it has moved. So right side's the client, left side's the server, and notice how now I can move it here on the client. And if we do it the other way around, the server now takes ownership. PurrNet, take ownership. Now the server can move it. Right, so it's really that easy to sort of get started working with networking with a system like PurrNet. And again, with many systems like Mirror and Netcode as well. Okay, cool. So now we have a bit of an understanding of what this is a networked object, right? Let's go into our prefabs folder and let's just make this cube into a prefab. So now it's in the network prefabs here. All right, cool. So now that we have our cube working, let's move into some of the next steps. So first of all, just to give you the ground understanding, this is essentially what the network identities does. Is it handles this sort of, spawning of it. It's it can be cross-referenced across the network. As I mentioned, going back to our drawing, this is ID 1, this is ID 2. This is exactly what the network identities are. It gives them the ID here. You can see this is ID 0. And actually, if I just go ahead and I copy a couple of these cubes, go on to the client here, reload, and I hit play and I hit play. Notice how now this cube will be ID 1, this cube will be ID 2, and this one's still ID 0. And this is exactly what I drew out here. This is ID 1, 1, 2, 2, and they're essentially a cross-reference, right? And that's what the network transform also handles, is when we then move them, they are, we are on the client, of course. When I then move them, they are moved again because they are cross-referenced. So essentially it's saying ID 0 has now moved to this location. That's pretty much what's happening behind the scenes. All right, great. With that in mind and that little explanation of the network identities, let's try and make our own network identity component. And this is where the magic will really start to happen. So let's just call this, I don't know, our test network script, whatever. You can call it whatever you want. The naming doesn't matter at all. All right, great. Now I opened up the script. And the very first thing that we want to do is, instead of mono behavior, we make it into a network identity. It can also be a network behavior. It's essentially the exact same thing behind the scenes. Network behavior, network identity, same. You can see if I enter the network behavior, it is just a network identity. That's all it is. Okay, cool. So we can make it whatever. For simplicity's sake, let me just call it network identity, just to make that nice and clear. And now there's some things here that are very important. Because when network identities act on the network, they have to be ready on the network, if that makes sense. Because you might be used to something like awake in Unity. Awake essentially is great, right? Because it runs actually before the item even exists in the scene, and then start runs on the very first frame of the scene that the object is visible. However, the network has very likely not actually spawned the object at this point. And this is where the network loop becomes important, because you should not start doing network things before the network is ready. So let's take a simple example. Let me make the onSpawned method. This is essentially the callback, and as you can see, there's two of them. This is the callback that happens when the object is sort of spawned and everything is ready. As you can see, there are two of them. The onSpawned without any parameter in there will essentially only ever call once. No matter if you're the server or the client. The onSpawned with the parameter will actually call twice for the host. So essentially this calls with the context of, are we the server or not? So in the case, let's say that you only want the server to do something, we can do if is not a server return, which means now only if we are running as the server in here, we can do whatever we want to. Or if we just take the other onSpawned, this one was also just fine. We actually have some other calls to do the exact same thing. So we can do if is not is server, if is not is server, which means if we're not the host, we won't get past this point, right? So we'll just return. And there's more calls like this, but let's start by just testing something out. So let me make a new serialized field, and let me get a reference to a, let's just get a network identity because we want to test spawning. So network identity. This could also just be to a game object, because the strong suit is that PurrNet actually handles spawning for you. So it's as easy as doing it in Unity. You just call instantiate for the network identity. Let's just give it vector3.0 and quaternion.identity, just for good measure. So just will spawn at 0, 0. All right, cool. So now when we instantiate something, and in this case, because it is a network identity, it will be spawned. If it doesn't have a network identity on it, it will not. But again, this could also be a game object reference. As long as it has a network identity on it, it will be automatically spawned. Okay, so let's try and put this on something in the scene. So let's just call this our test spawner. Let's remove the cubes for now. and let's put the test network on this. Now let's go and drag and drop our cube in here, and let's hit play. And boom, you can see now there's a cube in the scene immediately. And as you can see, this cube will be spawned, meaning now if the, oh, did I forget to save the scene? I might have. Hold on, let me go back, save the scene, hit play again. And let me go in here, reload the scene. Cool. Yeah, so now this test spawn is here. And remember, I won't spawn it locally because I'm not the server. But when I hit play, the cube will show up because the server will have spawned it. What we can do instead, actually, just to show you for fun, if we do not have this check, all clients will run it, or everyone will run it, both editors in this case will run the logic, meaning that we should see 2 cubes. So here we'll see 1 cube, and we'll hit play, and boom, now we have 2 cubes, because both of them will have spawned it. Right, and notice how the ID is 1 and the ID is 2 here. And more importantly, you can see the owner has been set automatically. This is part of the network rules, but we'll get into ownership in a little bit as well. Okay, so just stopping here very quickly. Now we have a hang of spawning. However, let's now try and do instantiate inside of a wake, just to test it. Now going back here, I'm going to start the server. And I'm going to start the client. And notice now how there's only 1 cube in the scene, right? And it has an ID, it's spawned. This is because the server spawned his, but notice this is in a wake, which means both instances of the editor would have ran it, right? Because they both have the test spawn in the scene. It exists, they should both run it, but there's only 1 cube. Now, why is this? Well, it's actually because the client one fails to spawn, because this is happening before the network is ready, which is why when we want to do things, let's do it from unspawned and ahead, right? So another way to do it could be to just do it in some method on the key click or something like that, but essentially it has to be later than awake or start. This was essentially just to show you network identities. They need to be spawned, they need to be ready. And there actually is a check for this if you'd want to. So we can debug.logout is spawned and then logout the is spawned here. So we can try and do that. And actually let's try and test that. So let's hit play. And as you can see, is spawned is false here, even on the host, and on the client, obviously it will also be is spawned false. And again, it would have to be spawned before it can actually start acting on the network. Cool, now let's revamp our test network script a little bit. Let's try and do something like sending an RPC. The reason why I want to send an RPC is because it's sort of the very ground of networking. So let's do that by, let's start serializing a field and make it a color. And this will just be the color that we'd want to set. Let's also just make a reference to our renderer. So that way we can change the color of the renderer. Cool. Now let's just do it in update. For example, if input.get key down, key code dot, yeah, let's just do a, then set color, and we'll send through, actually let's not send through anything for now. So let's make the private void set color method. And yeah, let's start by doing this actually. So let's do in renderer dot, and let's do shared material. Actually, let's just do material dot color equals to underscore color. Right, so now we will set the renderer's material to the given color. Right, so let's go and test this, and this will happen when we hit A. Let's go and put our cube back in the scene. So let me remove the test spawner, drag the cube back in, and we called it the network. What do we call it? Test network? Yeah, test network. Cool. Let me put the script at the very top just for simplicity as well. Right, let's drag and drop the renderer in here, and let's just quickly set the color. Let's set it to something like blue. And oops, let me make sure that the alpha is also high enough. And oh, again, now I did it. I was doing changes on the clone. This was exactly what I said not to do. Luckily, it's easy. Let's just discard the scene changes here. And let me go back onto the actual main one. Drag and drop the cube in, test spawn out, add the test network script, drag it, whoops, drag it to the very top here. Drag the mesh renderer in, make it blue, alpha up, and hit save on the scene. And there we go. So now we have a cube in here. And now I'll play, and we'll also have our client join. So boom, now they're both connected. They both see the cube. Now I'm going to hit A. Wow, it turned blue. On the client, it's not blue. And as you can see, we can also just go and make this yellow. I can hit A. Now it's yellow here. It's blue here. It's not syncing. What's going on? Right. Well, let's start by actually calling something over the network. And this is where remote procedure calls comes in. And it's very, very important you understand remote procedure calls because they're such a base part of networking. So going into here, let's start by doing a server RPC. Now let me just very quickly actually go over the RPCs. There are 3 RPCs essentially. There's the server RPC, that's the observers RPC, and that's the target RPC. Now, what do these mean? Well, essentially, in most networking, the server RPC will be a client telling the server, to run some code. The observers RPC will be the server telling all clients to run some code, and the target RPC will be the server telling a single client to run some code. This is essentially what all the RPCs are, right? So server RPC means client to server, meaning we are now telling the server to run some code, and I'll get more in depth with that in a little bit. But just to also clarify, PurrNet also allows a little bit more freedom than some other systems do. For example, here, the server can also tell the server to do some things. It'll just run the code as local. The observers RPC, with the unsafe rules, the clients can actually also tell all clients to run all code. And the target RPC, the client can also actually tell a single client to run some code. So with the unsafe rules, the client can actually also do everything that the server can. This is why I think the unsafe rules are really good, because it essentially allows you to take little shortcuts. Going back to just looking at this right here, you might be thinking, well, what's going on? How can a client communicate to a client? Well, it's actually not because there's a direct link between the 2 clients. It's just because PurrNet is handling the routing. So what you normally do if a client would want to tell a client something, you'd have the client run a server RPC, which then runs a target RPC. That would be how you would normally do it. But with PurrNet, we essentially just allow you to take out this, right? So the client can just run the target RPC, and just behind the scenes, we pretty much do this for you, right? So this is basically what's going on behind the scenes handled for you. Cool. So that out the way, what is an RPC? Or more importantly for you as the developer, what is an RPC? Because obviously there's a lot of stuff going on behind the scenes, a lot of magic with a networking system that I don't want to bore you with, and that's also really not relevant. However, an RPC is a command or an instruction for someone to run something. So looking at this right here, it's essentially the client instructing the server to run some piece of code. So in this case, whoever calls setColor is instructing the server RPC to run this method, which means it might seem counterintuitive, right? Because normally when we call some code, we will be running it. But in this case, when it's tagged with the server RPC, we will not be running it unless we also instruct it to run it locally. But that's another thing, and we'll get into that in a little bit. But in this case, when we call setColor, we will actually not be the ones running it, the server will. So if we are the server, obviously we will be running it. But if we're not the server, only the server will. So let's go and test this very quickly. So let's go here and let's start up the client too. And now let me try on the client. I'm going to move this over here. On the client, I'm not going to hit A. And notice how the client didn't change, but the server did. And that's because now the client has called setColor, instructed the server to run the code. Great. All right, so that's already a good start. And I think now you already have a much better understanding of it. So now with the unsafe rule set, what we can do is we can set this to an observers RPC, because this is telling all clients to run it. And you might be thinking, well, will the server run it then? And it will, because the server is a host, remember? Because it's both a server and a client. So therefore, the server will be running it. But if the server wasn't a host, if it was just a server, not a client, it wouldn't be running it. And that's an important distinction. It's only all clients that run this. Cool. So let's head back in and let's try and start this up now. And now let's try and do this. And now let me go and hit A on the client again. Boom. And now notice how they all went to blue. However, let's try another thing really quickly. So let's try and make this one yellow, and let's try on the host to make it red. And now let me go back on the client, and let me hit A again. And now this one turned yellow, this one turned red, which is because that's their local parameters. But so therefore we are not actually networking the color yet. We're just networking that you need to set the color to the parameter that you have. And this is where, synchronizing could come in. We could synchronize this color and what it's being set to, or even easier, we just send the color as a parameter. So we send the color here, which we will then set here instead of the local color, we'll use the color that's sent over the network. And then in here, we can send our local color. So essentially now the one calling it will also be the one instructing everybody that, hey, set it to this color, right? So that means now if I go and start the host and I go and start the client, now let me try and have the client set, for example, like a purplish pink color here. So now when the client hits A, they'll all go to this purplish pink color. When the host hits A, they'll all go to this blue color, right? So now we're essentially telling the whole network, go to what I'm saying, right? Go to my local parameter. because we're essentially sending the parameter over the network. All right. Now, another thing with these parameters that's very important is there's a lot of things that you can send. You can send network identities directly. You can actually send game objects and transforms directly if they have a network identity on them. Again, the network needs to be able to cross-reference, remember that. We can also send all default values like floats, quaternions, vectors. We can send a whole bunch of stuff. And actually, PurrNet can even handle custom structs for you, right? So if you go ahead and you make a private struct, struct, test struct, and then we make, but the thing is everything inside also has to be serializable, right? So we can send this here, my struct, and then for example in here we can have a public color. And then up here, what we could do, again, this is obviously a very simple example. Let's just do my struct equals to new test struct, oops, not test network, test struct. And then we'll set the color equals to underscore color. And now we'll send the whole struct in here, like so. So now we essentially made a custom struct. And of course here we now need to set it to my struct.color. Now we've essentially made a whole struct. We're sending that over the network and that contains a color. And this could hold all sorts of data, right? This could also hold a public int value or whatever you want to call it. Like you could have all sorts of data in here. Just to show you, this also works with custom data very easily. So if I now hit play and I hit play and now I'm going to hit A and now you can see it got set to blue as well because I have the blue color. We can change it to anything, green, boom, green, right? Cool. So we can even send custom data over the network very easily. However, there will be certain types of things you necessarily can't send over the network. And that depends on serialization and some more advanced stuff. And if you want to read into that a little bit more, I will push you to the documentation where under systems and modules, network manager, I believe, search for it. Serialization. Oh, it's on the guide, sorry. Network and custom classes, structs, and types, where that's all about serialization. And hopefully that can give you a view if you want. I think that's a little too advanced for this video, but might be good for our next one. Regardless, I hope you get the idea. You can send parameters in here, and you can send as many as you'd like, right? You can send much more. I could also send a bool, should set color, or whatever, and you can make that. And then in here we can send true, and then everybody would receive true, right? All right, great. But let's try another thing really quickly. Let me just go away from the struct again. This is unnecessary right now. Let's just set the color, just set the color, dupe, and this will just be underscore color. Right, and let's move the struct. So now we're back. But now let's try something else. Now I will try and start it on the host, and then I will hit A. Now you can see now it's blue. I'll start it on the client, but it's still red. Well, this is because the signal was sent before the client joined, which means he never got the signal to change any sort of color. Now, what are we going to do about this? Well, there's multiple ways you can go about this really. First of all, we actually have a call called onObserverAdded. This essentially is whenever a new player starts seeing this object for the first time, typically when they join, there will actually be a callback where you could essentially send the color, for example, again, or whatever you'd like to do. But even easier, the RPCs actually have something called bufferLast. These are parameters, so we add a parentheses around, and then we can add parameters in here. And you can get familiar with the parameters that are in here. You can see them here. We can change like the channels, whether it's bufferLast, how long to timeout, so on. Exclude owner, exclude sender, exclude server, run locally. But we're going to be using bufferLast right now, and I'm just going to set that to true. BufferLast essentially means that when a new player joins, they will get the newest piece of data, right? So let me, for example, go in here. Let me start up the host. Let me hit A to make it blue. Let me then hit A to make it green. Let me then hit A to make it yellow, like that, for example. Now let's try and have the newest player join. Boom, he joins, and he gets the call with the yellow color, because that was the latest color. So he didn't call any of the blue, green, whatever. He only called the yellow one, because that was the latest. That's what bufferLast means. And this is essentially some level of synchronizing. Obviously, it's a simple level of synchronizing, but it is synchronizing because you're essentially ensuring that everybody will always have this call because it's buffered last. But let's get into some actual synchronizing, right? So one of the easiest ways to do this, let's try and set up, for example, that could be like a health bar, right? So let's try and set up a number to synchronize. And actually, we can serialize this as well. PurrNet allows that. but we can make a private, and then we have sync, and we have a lot of sync types. And these are also in our documentation. So going in here really quickly, systems and modules, we should be able to see under network identities, sync types here. And you can see we have a bunch of different sync types: sync var, sync list, sync array, sync queue, sync dictionary, sync event, sync hashhead, and sync timer. So we have a bunch of different sync types, which essentially are things that will automatically stay in sync for you, and they'll handle it for you and the logic. And sync types in PurrNet can be both owned by server and by client. We'll get into ownership in a little bit, so let's keep everything simple and just keep it on the server. Now let's just have this like be an integer, and let's call this the health. One thing that's important is you set this equal to new. And you can have some parameters in here. You can have like the default value. We'd, for example, want 100 as the default value. You can also, as you can see here, oops, it hit it, there we go. You can see the send interval, like how often it should send and whether it's on or auth. In this case, let's just set the initial value to 100. And that's essentially all we're going to do right now. Now, instead of setting color here, let's make a new input. And let's just do if input.getS, for example. What we'll do is we will call a server RPC, because now this is server owned, so we only want the server doing it. Private void. Let's do take damage, for example. And then int, that'll be the damage to be taken. And then in here we can just send set damage. This send damage to 10 damage, for example. Right, so now everybody, when they press S, will tell the server to remove 10 damage. What we can do with the health here is we're now do health.value, because this is remember, this is a sync var. This isn't strictly an int. So you can't just do health minus equals to 10. This won't work on minus equal to damage. Won't work because it's a sync var. So it's a type of sync var, but the way that we get the integer in it is by doing .value. And this int can also be anything that's serializable. This could also be your color. Whoops. What did I just do? This could also be your color. This could be a vector 3. This could be many things. But in our case, we want it to just be an integer. Right, and because it's serialized, we should be able to see it in editor. So let's go out here, let's check our cube. And see if we expand health, we expand value, and now you can see the value is 100. You can also see it's not owner auth, and it doesn't have the thing var. It's important to note that when things are serialized in editor like this, changing them in code no longer has an effect. So if I now write 50 here, for example, and I go back into editor, this value will still be 100 because it's already serialized in Unity. You can see value still be 100. Okay, so I'm going to go ahead and hit play. And now I'm going to hit S. And you can see now we took away 10 health. S again. Now we're on 70 health. Now let's have our other client join. So I'm going to hit start. I'm going to show the value, and you see now it's already 70. And when I hit S now, we also take 10 damage at a time. And as you can see, that's also synchronized on the client. And you'll notice how this is actually very similar to if you just did an observers RPC with buffer last true and essentially just took away some numbers, right? The difference is this will actually, catch up with the correct number. So if I stop playing on the client, start playing on the client, it'll jump to 40 again. Whereas if we did this before with a buffer last, it will only just have deducted 10 damage from the initial 100, or in this case it says 50, but from the initial 100, which means we would have been at 90, not 40, if that makes sense. Now we could essentially do our own synchronizing, just to give you an idea, because behind the scenes, it's very much a similar thing that's happening. So let's actually try and make sort of a local health here. Private int underscore local health. And actually, let me serialize that too. And let's set it equal to 100 as well. And now let's just try and do that with A. So instead of setting color. So let's remove the color, the renderer stuff. And let's not do set color anymore. Well, let's keep the observers RPC here. So let's do this and call this like set health, for example. So now everybody can call set health, and they will send int health, like so. And they will set their local health equals to health. And what we can now do is we can call set health up here with the underscore local health minus 10, for example. Right, so now whenever we hit A, the local health will be set, essentially be completely set. So now we're locally calculating the change. We're not calculating it on the server, and then just telling everyone that this is now the health. This is essentially very much the same idea. So now let me go in here. Whoops, I forgot to stop playing. If it start, notice the local health. I'm just gonna collapse this. Notice every time I now hit A, it'll go down by 10, right? So now it's 70. Now going in here, hit play, local health is now 70. And when I hit A here, it'll go down by 10 as well, every time. All right, however, keep in mind with such a synchronizing setup as we have right here, this is not this is not recommendable, because there's a reason why we only want sort of one source of truth, which is what we have with our health here. In this case, right now, this is server auth, meaning only the server is able to control it. The reason why we only want one source of truth is because let's say that two players are shooting at the same thing at the same time. Well, you know, you shoot, I shoot, let's say we hit him at the exact same time. We would want him to take 20 damage, but because we're both now calculating locally, -10, he will actually only have taken 10 damage. It'll just be called twice. You know, that damage will be, let's say he has 100 health, you hit him, I hit him. We'll both do 100 -10 and then send 90, which means he'll now only be at 90 health. Oh, sorry, here. We'll only send 90. Whereas here, with take damage, we will both have called take damage with 10, which means he will have taken 20 health, because both calls will arrive and it'll be synced by the server. So I won't recommend synchronizing necessarily like values like this. For values, I would use the sync var. But it's really just to show you. Now, when it comes to actually utilizing the sync lists and the sync arrays and all these other sync types that we have, I'll actually defer to my other video on that. I think you guys have a good enough understanding on it, and I have essentially a video on sync types, and you'll also always find them on the individual ones. You can see sync var here has a video on how to use the sync var. Now, the sync list, sync queue, sync array, and so on don't really have videos, but they're very similar. So I think if you want a little more in depth, always go watch the individual videos where I will be going over them a little bit more. Now, moving on. I know I very briefly skipped over synchronizing, but there's really not that much to it. It also has some callbacks actually, which I just want to clarify very quickly. So if I do .health, and then there is a unchanged value, or like unchanged callback, which you can now do += unchanged. Of course, be careful, always unsubscribe again. So let's do undestroy. Whoops, that was not undestroy. Nope, that's visual scripting. What's going on there? There we go. Unity's undestroy. Undo _health dot unchanged -= unchanged. And now we can make this method, which is a callback to an int. This will be our new value. And now we can just try and log here. Debug.log. Oh, actually, let's just do a new value here. I'm going to skip over this rather quickly because this is just standard C# stuff. So essentially, whenever the value is set, so you know, every time in this case we take damage, it will log the value, right? So let me go and just try and show this really quickly, just so you can see that it works. Now when I hit S, you can see now I went to 90, 80, 70. If I go on my client and I join, you can see he will now get the callback for 70. And if he starts taking damage for us, we will get every call as well here. This callback is essentially what you can use. For example, let's say you wanted some health text over the player. You would tap into this. You could, for example, very easily, actually we can just do that. Just do serialized field, private, let's do TMP _text, text mesh pro text. Let's do _health text. And what we can just do here is the health text dot text equals to new value dot toString. Right, so every time the health changes, we'll now set the text above the player. Now let's go in here, 3D object, text mesh pro. Oops, I need to import TMP essentials. And let's just call this health text, for example. So let's just tilt it a little bit, put it above the player. Oops, text. Put it above the player. And let's make it way smaller, like 0.1 of the text size. And let's just write in 100, for example. Let's center it, make it fat and a little bit bigger. 60, for example, something like that. Right, so now you can see we have 100 here. And when I'm going to save the scene, have the client join. Oh, here. So you can see what now when oh, of course we didn't drag and drop it in. There we go. Drag and drop it in, save the scene again. I'll reload the scene, join. Now when we hit S, you can see now the health text will go down as I hit. Doop, 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 doop. And as you can see, that's about it. And this is essentially where you'd handle logic that you'd want after changing the health. You could also have it on the server. That'll be completely valid because on the server, it'll pretty much be immediate. So you could also just do if health.value is less than or equal to 0, for example. Then you just debug.log. Something like has died. And what you could also do is you could just set it to 0, right? So you could set the health.value equals 0, something like that. So now the value will never be able to go lower, but it will keep logging out on the server only that he is dead. So if we go on to the client here, I'm going to show you, I'm going to start spamming S, boop, 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 boop. And you can see now when I spam S, it says has died, never goes lower than 0. Okay, I know I'm skipping over some of this a little bit quickly, but the reason for this is because I think you have a decent enough understanding. I've been mumbling enough, and I think we're already about an hour or so in. So now let's continue. Now that's past synchronizing. Now let's try and set up a basic player, right? Something you can move around, we can spawn him, and you can control him. And actually, let's just convert our cube here into our player. So instead of test network, let me just make a new script. And let's just call this one like player movement. And I did it on the clone, because I'm a buffoon. Of course I did, why wouldn't I? Here, player movement, there we go. So opening up player movement. Now let's try and, first of all, remember, let's make it a network identity. And now let's figure out how we want to handle the movement. First of all, let's just do it very, very simply. So let me just make a parameter up here. Let's call it private float underscore speed. Let's just set that equal to something. I don't care what it is. And now in our update, or I guess we can do it wherever. Yeah, let's do an update. We'll just move the transform. I don't care much about this. Let's keep it extremely simple. So let's do, I think you have the input.getAxis. I haven't used these in a while. I think it's getAxis, and I think it's horizontal, right? That is the one axis. So I think what we can do is we can just build our input from this. Let's just do vector2, call it input, equal to new vector2. And then from that, we'd want the horizontal axis and we'd want the vertical axis. So like this. I'm pretty sure this should give us our input. And now we can just use this to move the transform. So let's just call, let's just do transform dot translate, for example. Or actually, let's just do transform dot position. Let's just move it directly. And then, or actually, let's have this be our move vector. Hold on. We'll make this a vector 3, and then it'll be 0 on the y-axis, and this is the move vector. The reason for this is just, I hope you understand simple single player code, so I won't be explaining that too much. And we just have the move vector times delta time times our speed. I think that should mostly just have us moving. And I know I'd want to put them in parentheses. We can do that. All right, cool. So let's just quickly plop this onto the cube and just confirm that works. So let's plop this on here. And let's have the test network off. And I did it on the clone again. God damn it. I am breaking all my own rules. Let's remove the... actually, I guess we can keep the test network around, actually. Oh, I'm an idiot. I'm an idiot. Absolute idiot. We want to set this back to 0, and we want to do plus equals to. Don't mind me. This was exceptionally stupid. All right. All right. Here, now I can move around. There we go. Yeah, so now it moves. Okay, cool. So I'm going to enable the, box cloud doesn't matter much, but I'm going to enable the network transform, and I'm going to have the client also here. And now notice how the client cannot move it around. I'm trying to move it WSD right now, but the host can. And it has moved for the client. That is because we are right now, it's not the controller, the client. And this is essentially where we want to spawn 2 of them. Another thing that's good to do is, if we go into the unspawned, we already now at this point actually have ownership. So what we can do is we can just say enabled equals to is owner. This will now disable it if we're not the owner, and it'll be enabled if we are the owner. And update will only be running for the owner. Right, so going back in here, the thing is now nobody's the owner, right? So if I hit play even on the server, I can't move it around. But and if I take ownership, still can't move it because we did it on the unspawned. However, this means now we actually have to spawn the player. Now let's just save the prefab here of the cube. Let's go into Network Manager or anywhere really, and you can add a player spawner component. This can be added anywhere. It doesn't have to be in Network Manager. You can drag and drop the cube in here and hit save. So now when I hit play, you can see a cube is spawned, and this is now my cube. And now if we go in here, hit play, the cube is now spawned, and this is now the client's cube. Cool. So now we can actually move around, and we have 2 that can move around at the same time. And this is essentially just a simple setup of how a player could look. And this works really well. All right, cool. So that's nice. We know that now works. Cool, so now we already have very simple movement, and if you want a little bit more advanced movement, I'm once again going to just defer to my own setup here. In the getting started tutorial, I had a movement script and essentially a single player movement script, and I just showed how to get that working very easily with networking. All right, cool. So now we have 2 players moving around. and the player spawner essentially handles the spawning. If you ever want to make your own player spawner, which in a lot of cases you might want custom spawning, just have a look at the player spawner component. It's actually really simple. Either that, or you could do what we did in the beginning, where we, in the on-spawned, we just instantiated something, and we just had every player essentially instantiate their own thing. You could do that too. That's completely valid. You can run it exactly how you'd want to. So, now we have this working. And you have a simple concept of spawning as well. I feel like the last important thing that we really need to cover is the understanding of ownership. Now, ownership is important because with networking, in order to make sure things stay aligned, we need a single source of truth. Now, this single source of truth is going to come from, well, somewhere. And that's where we define it, right? So let's go into our cube again. Here. And now I'm going to make the, first of all, let me just remove this local thing. We don't want to confuse things anymore. I'm just going to remove that. Remove that. And now you can see it's the server that's handling it. I don't want that actually. So I'm going to take this away. It's not going to be the server that handles it. I want it to be the owner that handles it. So normally in a setup, when you set it up directly in here, you'd set up owner auth to true like this, for example. However, remember, we already serialized it in editor, so this is not actually going to work. This change is not going to do anything. We have to go do it in editor. But now we can do a similar thing to what we just did before in here, and we can go into the on-spawn and just say enabled equals to is owner. Because we are updating it in the update. So right now, let me just change it to something like X, so it doesn't happen while I move around. And then the take damage will just happen locally. And here when we die, we can actually also just despawn the object, which you just do by destroying it, as you would in Unity. So let's remove the log, let's just destroy it. And that should be it. So now when we hit X, we will essentially damage, well, ourselves in this case. But the thing is, because we're going to make it owner auth, that means that we're the only ones allowed to damage us, if that makes sense. So let me go into the health, owner auth, and make sure that's set to that. I'm going to start the server, I'm going to start the client. I'm going to move out of him here, and as you can see now we move around, and as I hit X, you can see I will take damage on myself. The server can do the same thing over here, will take damage on himself. As you can see, as I reach 0 damage, boop, I'm now despawned, which means I've died. And there we go. Now we have sort of a basic health system as well, and despawning. And the more important part of this really that I want you to understand is the ownership aspect of it. If now I went back to add the server RPC here, this would very much yell at us saying you're not authorized to change this sync var. So if I start the server, I start the client, and now the client will go and call to try and take damage. And now, as you can see, it'll say invalid permission when setting the sync var health on cube. So with PurrNet, we're really trying to give as much information as possible, and this should really be all the information you need. It says there's clearly a sync var that doesn't have permission because, likely ownership. You can see that it's an int sync var. It's called _health and it's on the cube clone. Can't really give you a lot more information than that. So as you can see, it'll work on the server because the server is just telling itself to take damage, which works fine, but it doesn't work on the client. And this is where ownership is really important. You have to be aware of who can change what. And with the setup we had earlier with the local health, everybody was allowed to change it. But again, that's where the insecurity came of what is the actual value, right? Because if we're all shooting at the same time, we'll all be setting the value. So I definitely prefer this. And let's say that you wanted to, again, normally something like health, I'd probably have beyond the server, and then everybody tells the server to take health. But if you wanted, let's say it's a game where you don't damage each other, but the environment damages you, well, you'd probably want the health to be owner auth then. The strength of owner auth, and this is also where it really matters. Let's open up a notepad. The strength of owner auth and why we build so much owner auth stuff into PurrNet, or at least allow you to work with owner auth, is because owner auth is inherently just faster, it's more reactive, it's more responsive. And this is typically the issue of networking, right? Is you will have ping. So let's say that we had an environment, right? And we had a spike. Our player hits the spike. So player hits spike, he will take damage, right? Normally in a single player game, this will feel instant. You hit the spike, take damage, you do some knockback, whatever you want to do. But if now this then had to be routed through the server, which then had to be routed back to the client, or where the server essentially does the taking of damage, which will then be routed back to the client, we'll all of a sudden have this kind of change of moving data, right? So we have essentially the client to server, or it could just be that the server sees it actually, yeah. So if it was really bad, it would be like this actually. So the client sees the spike, tells the server takes damage, tells the client. This could be not an uncommon case of how to do it, but notice how the data is going from client to server to client. This is slow. This means you have a full round trip time. So if you have a ping of, let's say, 100, right, that's 0.1 seconds. That's essentially a round trip time, which means it'll take 50 milliseconds to reach the server. The server will do its calculations, take 50 milliseconds to go back, which wouldn't feel good, right? You hit a spike, you wait a little bit, and then you take damage. That would feel bad. That would feel terrible. Right, let's say that we make it a little bit faster. The server is what sees it. Well, the issue is if you're the controller of your position anyway, you're going to have the full round trip time anyway. It might seem counterintuitive because, right, it's, the client doesn't have to tell the server it hit it. But the difference is you will also be a little bit behind, right? The client will move essentially in front of where the server sees it because of the ping as well. This is a pretty easy concept to grasp, hopefully. But essentially, let's say we have two players, right? Let's say that this is what the server sees, you're running to the right, and this is what you see, right? You're essentially running to the right here, this way. There we go. And that's because, you have to move, then tell the server, hey, I have moved, and then the server has to update the move position. And, again, because of ping, this will inherently just be a little bit behind. There are ways to make up for this, but these are more advanced techniques. Either way, moving on. This is why the client auth comes in so strong, because the client will see that the player hits the spikes, will take the damage, and just tell everyone else that, everyone else will essentially know, or essentially through the sync bar, that I took damage. But the thing is, everything will have the same delay for that, right? So when you take damage locally, the value will change immediately. So what you will see is you hit the spikes, immediately take damage, and then you tell everybody else. And this might sound slow, but again, as I just mentioned with the positional stuff, the position is also slightly behind. So when you take damage and you send the information that I took damage will also be when they see you hit the spikes. And this will be how you make multiplayer feel the most responsive. Obviously, again, this also means that when everything is owner auth, it's also in that sense unsafe. That's why we call the network rules unsafe. Because when clients do everything, clients can also cheat, right? It would be easy in our case here, for example, for the client to just tap into the health, change the health, and tell everybody I have 1,000,000 health. You could do that. This method is not cheat proof, but I will also just stress, and I can't stress enough, stop caring so much about cheat proving. It's really not that important. Now, talking about ownership really quickly, as the very last thing here that we're going to do, is also how do you control ownership? There's two ways essentially of doing this. First of all, the network rules will automatically be giving you ownership. So if we just go in here very quickly to network manager and we look at the unsafe rules, there's spawn rules here, and as you can see here, there's default owner in the spawn rules. You can make your own rules. Actually, let me just copy these and put them into the assets folder just so we can modify it. So there's a default owner, there's spawner if client only or none. That's essentially the settings that we have here. Also, who can spawn, only the server or everyone, who can despawn. There's a lot of settings here, and it might be a good idea to familiarize yourself with, but yeah, it's very good. Either way, it'll be spawner if client only, meaning that when you spawn something, you will immediately be the owner of it. Right, so that would be, let's say that I, as the client, spawn a bullet, I will be the owner. But let's say that you wanted someone else to be the owner. Well, what you could do, let's just make a private void test spawn really quickly. I'm not actually going to spawn anything, but let's just say var new spawned equals instantiate, and let's just instantiate some prefab, and that's what we spawn. Right, so we spawn this prefab. Actually, let's make it a network identity of prefab. So new spawn, then we can do dot set, dot give ownership, it's called. And this is where player IDs come into play. Player IDs are relevant throughout the network, but I will just say go watch the video on it. I think already you have a good understanding of the network, but the player ID is essentially sort of your ID card to the club, right? So when you join, and this was what you actually saw when we hit play, and you saw that little thing below, the ID is essentially like, you're player 0, you're player 1, you're player 2, and so on. That's what the ID is. And the ID can very easily be sent over the network with RPCs and things like that as well. And this is what you'll use to give ownership as well, right? So for example, my local player, you can do local player force. That will be the local player, or you can just do local player. That'll be us, right? Local player will always be us, no matter, and this is very, very important to not confuse. If I call local player on your player, it's still me. It's not you, right? If you did owner, then you would get the other player. But if we did local player, we get us. We always, always, always get us ourselves with local player. And that's important to understand as well. And the same with all of these calls, actually, just to clarify. There is server and is client and is host calls. They're local. It doesn't matter which object we're on. It doesn't matter if I'm on your object. If, let's say, I am the host and you call is host on my object, doesn't change anything. You are not the host, because is host is just local to you. I really hope that makes sense. So it'll always be the local player. This is where, again, you have to sort of think back to the presentation of we're not in the same world, right? Think back to this stuff. We're not in the same world. So you're still checking local stuff at that point. The only way to essentially check for other players could either be, in the network manager, which you have access to. You can do something like clients. You should be able to see, players. I think it's called players here. There we can see all players in essentially a list format, or you can do something like getting the owner on the current object, right? So do owner, that'll be the object that we're in, the network identity. There's plenty of ways to go about it. There's a lot of stuff I still haven't explained here. Networking is really difficult. There's a lot of concepts to it. But hopefully, mostly this idea or understanding of you're not actually in the same world, it's just mimicking each other. As long as you have that understanding, you have a really good foundation. And I would urge you to still go and watch through some of these sort of multiplayer guide videos. This one was really just to do a bit more talking, a bit more explanation about sort of the mindset, getting the idea. But please, I really urge you to go and give these a watch, get a better understanding of the individual concepts to work with. Whereas I was just trying to give you a broader understanding in this one. So hopefully you've liked the video, you've liked the format a little bit. I know it's still rather loose. I didn't prepare much other than that little presentation. So I haven't really done a lot of upfront work on my part. But I still hope that it worked out okay. I hope my rambling wasn't too bad. And I hope that you learned something new and that you feel a little more confident and comfortable moving into networking yourself. That's about it. I hope you will leave a like, comment, and subscribe. And I see you in the next one.